This video talks about the laboratory, but I'll just take you through the laboratory testing as well. And from employee logistics to equipment maintenance, nothing is going to be skipped. I may not show some in the video, but at least the main production of yarn in the video is what I'm about to show you. I'm just saying that nothing is going to be simplified beyond the fact. Let's begin at the source. A banana plant is not a tree. Botanically, it is a giant herb. What looks like a trunk is actually a pseudostem made of tightly packed leaf sheaths. This pseudostem grows from an underground corm and supports the leaves and then fruits above the ground. Each pseudostem produces roots only once. After the banana bunch is harvested, the pseudostem is cut down to allow a new shoot to grow. For decades, these pseudostems were let rot in the fields. But now, in fact, I'm talking about as at 2026, they are increasingly treated as industrial raw material. The pseudostem contains long cellulose fibers running vertically through its structure. These fibers are strong, flexible, biodegradable, and suitable for industrial use. Chemically, banana fiber is composed mainly of cellulose and with smaller amounts of hemicellulose and lignin. This composition gives it tensile strength and makes it compatible with textile processing after treatment. Banana plants grow in tropical and subtropical climates. Well, at least they grow better. They require warm temperatures, regular rainfall, and fertile soil. Major producing countries include India, Brazil, China, Ecuador, Ghana, and the Philippines. In these regions, banana farming is continuous throughout the year, although individual pseudostems kind of follow a growth cycle of about 9 to 12 months. Each pseudostem can only be harvested once, but the plant itself is perennial. After harvest, new pseudostems emerge from the same root stem. This makes banana farming a continuous source of fiber raw material without additional planting. Once the bananas are harvested, like when I'm talking about once they're harvested for food, the pseudostems are cut down manually or mechanically. Timing is critical here. The stems contain a high percentage of moisture and begin to decompose quickly. So to preserve the fiber quality, they must be processed within days, sometimes within hours. The cut stems are transported from one plantation to processing centers. This requires tractors, trucks, loading crews, and scheduling coordination with farmers. In regions where banana fiber is industrialized, contracts are signed between processors and farming cooperatives to ensure predictable supply volumes. Now, we are entering into the factory now. This is where it gets even more exciting. The first thing that happens inside the processing facility is preparation. The pseudostems are trimmed and split lengthwise. Each stem contains multiple layers. The outer layers are tougher and contain more non-fibrous material. These are separated from the inner layers, which contain higher quality fibers. This separation can be done manually in small facilities or mechanically in large plants. This video that you're watching now is the industrial processing, which means mechanized handling, conveyors, and continuous flow of the systems are all in place. Now the next comes decortication. This is the core fiber extraction stage. The split pseudostem layers are fed into a decortificator machine. Inside the machine are these rotating drums, or I'll call it blades. They scrape away the soft plant tissue while leaving the long fibers intact. Water is often used during this stage to enhance or probably to reduce the friction. It also washes away the residue and also prevents fiber damage. What comes out of the decosificator is not yet clean fiber. It is a bundle of long fibers mixed with sap, pith, and plant residue. This material leaves immediately into washing systems. In washing systems, fibers are sprayed or immersed in clean water to remove remaining organic matter. Industrial systems use controlled water flow and filtration so that the waste material is separated and then the water can be recycled. This step is very important for hygiene, fiber quality, and downstream processing. After washing, the fibers are dewatered. This can be done using rollers, presses, or centrifugal systems. Removing excess moisture prevents microbial growth and also prepares fibers for chemical or biological treatment. At this point, the fibers are strong but stiff. Natural plant gums, lignin, and pectin still bind the fibers bundles together to make the fibers soft or flexible and also suitable for spinning. Degumming is required. Degumming can be done chemically or enzymatically. Chemical degumming typically uses controlled alkaline solutions. Enzymatic degumming uses specialized enzymes that break down non-cellulosic materials without damaging the cellulose fibers. In 2026, many facilities prefer enzymatic methods because they are more environmentally friendly and produce high-quality fiber. Now, after degumming, fibers are thoroughly rinsed and neutralized. They are then dried in controlled conditions. Now, drying, they use drying tunnels to regulate temperature and airflow to prevent brittleness and uneven moisture content. Once they are dried, the fibers are conditioned. Conditioning means adjusting moisture levels up to the industry standards. Fiber that is too dry becomes brittle. Fiber that is too moist risks mold and inconsistent processing. Okay, so now the fiber is ready for conversion into yarn. Banana fibers are naturally long, or depending on the intended use, they may be cut into staple lengths. Staple fibers can be spun using conventional textile machinery, often blended with other fibers such as cotton or recycled polyester to improve softness and uniformity. The fiber then enters the opening stage. Opening machines separate fiber bundles, remove tangles, and prepare materials for alignment. From here, the fiber goes through carding. Carding machines align fibers parallel to each other and remove remaining impurities. This produces a loose rape-like structure known as a silver. Multiple silvers are combined and drawn. Now, drawing equalizes thickness and improves fiber alignment. Sensors continually monitor mass variations and adjustments, drafting ratios automatically. Next is roving. Roving adds a small amount of twist to the fibers and winds them onto bobbins. This prepares the materials for final spinning. Spinning is where fiber becomes yarn. Spinning machines stretch the roving and insert controlled twist. The amount of twist determines the strength and texture of the final yarn. The yarn is wound onto cones or spools ready for use or for sale. Now, throughout this process, quality control is constant. Modern facilities have laboratories on site. These labs test fiber length, tensile strength, moisture content, and uniformity. Microscopy is used to detect contamination in the process. And then chemical tests are also used to verify that degumming was effective and safe. None of these work without people, by the way, just to remind you. A banana fiber factory operates with multiple teams. Machines operators oversee equipment and monitor control panels. Maintenance engineers inspect mechanical parts, replace worn blades, calibrate sensors, and diagnose software issues. Quality technicians collect sample and run lab tests. Logistics staff manage inbound stems and outbound yarn shipment. Safety officers ensure compliance with chemical handling and machinery regulations. Employee logistics are a major operational requirement. Workers often operate in shifts. Remember, His Excellency Mahama's 24-hour economy? We will be running shifts. So especially in facilities running continuously or running continuous productions, shifts are important. Transport is provided in many regions to move employees to and from rural processing sites. Facilities must provide protective clothing, clean water, sanitation, medical support, and training. Behind every machine is an engineering story. The equipment used in banana fiber processing does not appear by accident. Mechanical engineers designed the decorticators, conveyors, presses, and dryers using computer-aided design software. Now, who designs the software? People. They simulate load, stress, blade wear, and vibration. Electrical engineers design motor systems and power distribution. Automation engineers program programmable logic controllers that regulate speed, pressure, and safety shutdowns. Robotic engineers design automated feeding systems. Software engineers create interfaces that allow operators to monitor performance in real time. Sensors track temperatures, humidity, fiber flow, and machine health. Manufacturing the equipment also involves precision machining, casting, assembling, and testing. Each machine is tested before installation. By who? By people. Calibration ensures consistency across production lines. Now, maintenance does not stop after installation. Machines are cleaned daily. And who needs to clean it? People, most of the time. Components are inspected weekly. Sensors are recalibrated monthly. Full overhauls are scheduled manually and also every year. Preventive maintenance reduces downtime and protects fiber quality in all of these processes. The supply chain extends beyond the factory. Water treatment systems are required to recycle or process water. Waste fiber and plant residue are collected and often converted into compost or bioenergy. Electricity supply must be stable, often supported by backup generators or solar installations. Spare parts inventories must be maintained to avoid production stoppages. Finished yarn is packaged now, labeled, and shipped to customers. These customers include textile mills, packaging manufacturers, and composite material producers. Traceability is essential. Buyers increasingly demand proof for sustainable sourcing and processing, right? So, yeah, in 2026, banana fibers is gaining attention because it solves multiple problems at once. It reduces agricultural waste. It provides farmers with additional income. It creates biodegradable alternatives to synthetic materials, and it supports rural industrialization without expanding farmland. Similar processes also all the other production videos you have seen in this podcast today. So yeah, what you have seen in the videos today are not just machines pulling fibers from plant to stem. It is a whole system. It is agriculture meeting engineering. It is waste becoming value. It is an invisible supply chain turning something ordinary into something industrial. And once you understand it, you never look at a banana plant the same way again. Now, with that overview in place, let's talk about the implications for Ghana. Imagine how transformative it would be if Ghana could also manufacture products like this, not just import them, but truly produce them at scale. This might seem ambitious, but it is feasible given the right investment and strategy. But the question is, should we do it at all? Should we go through this to produce yarn? We all know how much yarn costs, right? It is affordable. But if there is a country that has specialized in all of this and still can produce the final product quite cheap, why don't we source that and then use the funds we have to invest in Ghana's youth population? Now, if you ask me, one of the greatest assets that Ghana has today is its youth population. Yeah, Ghana has a large proportion of young people, like I said in my previous episode. Young people are flexible learners. They adapt easily to new technologies and are capable of acquiring the skills needed for modern Ghana. And we can use what we have to train Ghana's youth in, for example, foundational digital and technical skills, such as programming, mechanical engineering. I'm sure a lot of them are already in place, but I'm talking about something like vocational or training centers. So they could go into programming, mechanical designs, industrial automation, like mechatronics, electrical installation, robotic maintenance, quality control, and computer-aided design. Like a generation of skilled workers will emerge who can operate and maintain and even in the process innovate industrial processes for countries. I know we already have some Ghanaians who have invented a lot of things that is used all over the world today. Even the internet that I'm talking on right now, the fiber optic, was enhanced or improved by a Ghanaian, the late Dr. Mensah. Without him, today's internet perhaps may not have been working. So, if you ask me, these skills do not all need to be taught exclusively at universities. In fact, many countries successfully prepare advanced factory workers through technical and vocational schools, and including apprenticeships. These programs focus on hands-on skills that are directly applicable on factory floors. In parts of Europe, East Asia, and North America, many factory operators enter the workforce with secondary education supplemented by vocational certificates and specialized trade training. University degrees, are often reserved for, let's say, roles in engineering, research, process development, and advanced learning. I'm talking about the scientific aspect of the production systems. Operators, technicians, and machine programmers commonly possess industry-specific certificates or diplomas or vocational credentials that demonstrate competence in their trade. Now, this means every person is valuable regardless of their formal educational level. In many modern factories around the world, even after obtaining university degrees, individuals will have to complete a professional certification or a vocational training to qualify for a job. Degrees alone does not always qualify for a job, but having a professional certificate gives an advantage. In a well-structured system, a high school graduate might become a machine operator, a mid-level technician, or a CNC specialist, while someone with further training might become an automation engineer, a system designer, or a quality engineer. This creates layers of opportunity for people at all skill levels. For Ghana, this conversation must be really practical. It should be normal for senior high school students to specialize in at least one high demand skill. What I'm trying to say is perhaps it should be mandatory for every senior high school student to have a physical hands-on demand skill before they graduate. Or after graduation, while they wait for their results or WAEC results, they could engage in physical hands-on skill training before they go to the university. Now, I know that job demand shifts over time, yes, and training programs also do shift, but just know that the world itself keeps evolving, and so programs must also adjust accordingly. But then some skills such as electrical work, mechanical maintenance, industrial programming, quality assurance, and automation system operations cannot tend to have relevance for a longer period of time, let's say from 5 to 10 years or even more. And so this means that investors in education or investors in vocational training can focus on these areas so that they can gain their profits or benefit before changing to adjust to current trends, if you know what I mean. So it may be tricky to implement, but it requires planning, focus, collaboration between governments, educators, and industry. And simply put, it is doable, to be honest. It is really doable and already been done successfully in other parts of the world. Now, in the last episode, we also said we will talk about how to ship goods from China and how to ensure quality before shipments reach customers. This remains core to this series to support individual businesses on this path. there is Aj.vlogger Academy. Now, in the last episode, we also said we will talk about how to ship goods from China and how to ensure quality before shipments reach customers. This remains core to this series to support individual businesses on this path. There is Aj.vlogger Academy. Aj.vlogger Academy has created a practical short course that is going to teach anyone who wants to import quality products from China. Anyone, any business person at all, even those who already import from China could also benefit from this short course. Taking them from zero knowledge, you don't need to have even business knowledge. You can enroll. If you're already confident in ordering from China, negotiating, and you know the quality control of whatever product that you want to import, well, it's still beneficial for you, even including delivery. Now, this course is designed to be accessible even to beginners, like I said earlier on, and it covers the entire process from start to finish. You don't have to worry at all. After completing the course, participants can place orders via designated links that connect them directly to qualified manufacturers in China. They can also have access to OEMs and ODM factories directly, reducing reliance on intermediaries and often lowering costs. If language is a barrier or it presents a challenge, don't worry. We do have representatives at Aj.vlogger Academy who are available to assist you with communication, whether in Twi, in Ga, in Hausa, in major languages, and Chinese, especially when it comes to negotiations and logistics. These representatives are there for you. Now, for those who prefer to source products directly without going through the courses, Aj.vlogger Enterprise e-commerce platform offers another route. This platform connects buyers in Ghana and across Africa with Chinese suppliers in a streamlined, supported environment. For larger companies and institutions requiring professional guidance, Invisible has identified and researched trusted experts who provide industry-level solutions. There are consultants who will help businesses solve complex sourcing, supply chain, and supplier selection challenges. For example, a company in Ghana, Cote d'Ivoire, or Nigeria that assembles fans or refrigerators or, let's say, appliances, and perhaps needs a stable motor supplier, can be connected with verified specialists who will help select trusted suppliers from Europe, America, or Asia. These expert consultations are designed to be professional, strategic, and outcome-focused, helping companies to identify the right partners, negotiate terms, and ensure consistent supply for long-term operations. Looking ahead, in the next episode, we'll move beyond importing. We will also explore how Ghana can export to China. We will discuss specific products that Ghana can export. And most importantly, we will look at what Ghana can export that China genuinely needs. Real items with real demand on the other side of the trade relationship. As we wrap up this episode, remember this: the future is not predetermined. It is shaped by skills, preparation, training, and strategic choices. Ghana has people, energy, and potential. With smart investments in vocational training, practical education, and global trade integration, Ghana's workforce can participate in modern manufacturing and global opportunity in ways that once seemed unreachable. Thank you so much for listening to Invisible M. Stay tuned as we continue to explore the unseen forces shaping opportunity, progress, and real economic power. Adios. Bye-bye for now.
Momentum nanya krabare no me yesi machara yesi macharo mewo fiti tanya fawudi yesi mi atu me yendu baby mewo biare yota na wana kumam mogo pado yamba pesa minkum nyanka hu etim na kaminyi na yamfanka hu yamba jentum yanju no vi entem ha kura na me yesi machara yesi macharo obiara mbrana wo ma yamfa obiara mbrana wo ma yamfa na ne nyame bwa hen yamfa American